In this question, all lengths are in meter and time in second. Diagram show the displacement time graph. Find the distance the runner have traveled when t equal to 40. So from 0 to 50 and then 50 to negative 10. So 50 meter and then 50 meter and then 10 meter. So it will be 50 plus 50 plus 10, then it's 110 meter. Okay. Draw the VT graph. Okay, so draw the VT graph for 0 until 40. So V, we know that in the distant time graph, V is the gradient. So the t between 0 and 10, okay, the V will be, this one is 10, 50, this is 0, 0, 50 minus 0, 10 minus 0, 5. Okay. And then this is 40, negative 10. So the t between 10 and 40, okay, the V equal to negative 10 minus 50 over 40 minus 10. So it's negative 60 over 30, negative 2. Negative 2, 5. So we have the negative 2, 5. So for this one, then we have the 5 here. And this is the V 5, 0 until 10, 10 until 40, T, and then negative 2 is here. Okay, so this is negative 2. Done. So for the part A here, so we know that is what it travel is from 0 until 50 and then go back to negative 10. Okay. So it's 50 plus 15 plus 10. Total distance travel is 110 meter. A particle travel in a straight line as it passes through a fixed point O. The velocity is 3. Okay. So when t equal to 0, v equal to 3. So continuous this velocity for 60 seconds. So until 60, then the v is 3. Then decelerate at a constant rate for 15 seconds. So t is 60 until 75. The acceleration is negative 1.6. So the final velocity will be 60 plus 15 times negative 1.6. So 60 minus 15 times 1.6, then it's 36. The particle then decelerate again at a constant rate of 5 second to reach point A where it stopped. Okay, so the t will be 75 until 80. 5 seconds until it stopped. Uh, 1.6, not the it's to 1.6. So this is the v equal to v equal to 1.6 when t equals to 75. So the v is 3. Then this v is 1.6, this v is 0. Okay, so we have 3, 1.5, and the uh, this one. Okay, so 0 until 60 is so 0, 20, 40, 60, 80, 60. And then we have the 3 here, 1.6 is here. So 0 until 60 is 3. And then we have the 75 here. So 75, this, and then this. Okay. So this is 75, 1.6. This is 63. This is 0, 3. This is 80, 0. Okay. Next, find the distance between O and A. This is VT graph. So for VT graph, the distance traveled will be the area. So we will have the area 1 is a rectangle, and then we will have the area 2 is a trapezium, and area 3 is a right angle triangle. So 3, 1.6, 60, 15, 5. So the first part is 3 times 60, 180 meter. Then the second part will be half 3 plus 1.6 multiply with 15, 34.5. And the last part will be half 5, 1.6 is 4. So the total distance traveled will be 218.5 meter. Yes. Okay. And find the deceleration. Okay, find the deceleration in the last 5 seconds. So deceleration is the gradient. So gradient for the last 5 seconds will be 0 minus 1.6 over 80 minus 75. So this is the acceleration. Okay, so we know that the acceleration will be the gradient. Okay, so the deceleration is 0.32 meter per second square. Hmm. So we know that for the VT graph, so for VT graph, the gradient, the A acceleration is the gradient. Then the distance traveled is the area under the graph. Okay. Question number 3, we have a xt graph, distance time graph. So we need to draw the VT graph. We know that the velocity is the gradient. So this one is 50, 100, 70, 6500, 8550, 1250, and this is 00. So the gradient for the first part will be 100 minus 10 over 50 minus 0 is 2. 100 minus 0. Then this is the V1. Then this velocity is 0. The gradient is 0. Then the next one is 150 minus 100 over 85 minus 765. So it's 2.5. Yeah, this is 2.5. And this is the V3. So V4 will be 0 minus 150 over 125 minus 85. So it's negative 3.75. So this is V4. So we have 0 until 50, V is 2, 65 until 85, V is 2.5, then 85 until 125, V is negative 3.75. Yes, okay. So with this information, okay, we can draw the VT graph. So 0 until 50, V is 2, and then 50 until 60, V is 0, 65 until 85 is 2.5, and then 85 until 125 is negative 3.75 here. Yes. Okay. Total distance covered. So 150 plus 150. So it's 150 plus 150, 300 meter. Yes. Okay. Yeah. So from 0 until 150 and then 150 to 0. So total is 300 meter. Question number 4. Particle P move in a straight line. Displacement is 10 sine 2t minus 5. Find the speed when t equal to pi. So we know that v is the first derivative. Then differentiate of sine will be cos. Okay, so when t equal to pi, then v is 20 cos 2 pi. this is 1. So it's 20. Okay. Meter per second. Hmm. Find the value of t, which p is first at rest. So at rest, velocity equal to 0. So the graph for cos is like this. Okay, so this is cos t. Then we have 2 pi here. And then, but we have cos 2t. Then over 2. This is pi. Then pi over 2. Then this is pi over 4. Okay. And then multiply with 20. Then we have 20 and negative 20. So t equal to pi over 4. Okay. So t equal to pi over 4. Find the acceleration when it is first at rest. So we know that A is dv dt. Then we will have negative 40 sine 2t. So at rest, t equal to pi over 4. So when t equal to pi over 4, A will be negative 40 sine 2 times pi over 4. So it's pi over 2. Then this is 1. So it's negative 40 meter per second squared. Question number 5. In this question, unit are meter and second. Particle P travel in a straight line. Acceleration is 3t plus 2 to the power negative 1 over 3. When t equal to 2, so t equal to 2, v equal to 8, s equal to negative 4.8. Find the expression for the velocity at time t. Okay, so we know that v is integrate a dt, then it will be integrate of 3t plus 2 negative 1 over 3 dt. Then it will be 3t plus 2 to the power 2 over 3 over 2 over 3 times 3 plus c. So 8 equal to half 3 2 plus 2 to the power 2 over 3 plus c. 8 power 2 over 3. This one, if you press calculator, it will become 4. Okay. 8 2 power 3, then 2 power 2 4. Okay. So the c will be 8 minus 2 6. Okay. So we will have the v equal to half 3t plus 2 to the power 2 over 3 plus 6. Explain why p never at rest. Okay. So never at rest. Okay. So the v, okay, v equal to the half 3t plus 2 to the power 2 over 3 plus 6 will always greater than 0 for t greater than 0, greater than or equal to 0. Okay. So v always positive. So V always positive. So the P is never at rest. Okay. Find the displacement. Okay. Find the displacement uh, for P when T equal to 25 over 3. So we know that the displacement S is integrate V dt. Then it will be integrate half 3t plus 2 to the power 3, 2 over 3 dt. Then it will be 3t plus 2 to the power of 5 over 2 divided by 5 over 2 multiply with 3. Then the 2 here cancel plus d. So it's 1 over 15 3t plus 2 to the power 5 over 2 plus d. When t equal to 0, s is negative 4.8. So we can find the value of the d here. So we want to find the d. So negative 4.8 equal to 1 over 15 2 to the power of 5 over 2 plus d. Okay, so d, no, when t is equal to 2, not t equal to 0. So when t equal to 2, then this one will be 3 times 2 plus 2. So we have 8, 3, 6, 8, 8 to the power of 5 over 2. So uh, 8 to the power of 2.5. Something wrong. No, this is 5 over 3, not 5 over 2. This is 5 over 3. Ah, mm, I make a mistake here. This will be half. Then this is 5 over 3. So 5 over 3, 3. Then is 1 over 10, 3t plus 2 to the power of 5 over 3 plus d. 1 over 10, 3 times 2 plus 2 to the power of 5 over 3 plus d. 8, then 2. 2, 4, 8, 1632. So is d will be negative 4.8 minus 32 over 10. So it's negative 6. Negative 20. No, 3 over 332. Hmm. V here, I make some mistake here. Then plus 6. Should have plus 6 there. Okay. So plus 6. Then plus 60. So plus 6 times 2. Then minus 12. minus 12. So negative 20. Yes, negative 20. So the S will be this one minus 20. So when t equal to 25 over 3, then S will be 110 3 times 25 over 3 plus 2, 25 over 3 minus 20. So we have 50 there. So 27, then cube root will be 3, then 243. So we have 24.3 plus 50 minus 20. So it will be 54.3. Yes. So 54.3 meter. Question number 6. Particle P move in a straight line. Displacement is as displacement from a fixed point at time t in a second. Acceleration of this. So P have a velocity of 9. So V equal to 9 when t equal to 6. So A equal to 2t plus 4 to the power negative half. So V is integrate A dt. So it's integrate 2t plus 4 to the power negative half dt. Then it is 2t plus 4 to the half. And then power half divided by half times 2 plus c. So when t equal to 6, v equal to 9. So 2 times 6 plus 4 to the power half plus c, 16. Then square root of 16 is 4. So c is 9 minus 4, 5. So v will be the 2t plus 4 to the power half plus 5. So find the displacement. So we know that the S is integrate. So S is integrate V dt. So integrate this 2t plus 4 to the power half plus 5 dt. Then it will be 2t plus 4 to the power 3 over 2 over 3 over 2 times 2 plus 5t plus c. So S is 1/3, and then 2 6 plus 4 to the power of 3 over 2. So S equal to 1/3 when t equal to 6. So what will we have here? Plus 5 6 plus should be D. We have C just now. This one we use D. So D will be 1/3 minus this one is 16. Square root of 16 is 4. Then 4 power 3 is 64 over 3 minus 30. So negative 51. So the S is 1/3 2t plus 4 to the power 3 over 2 plus 5t minus 51. Okay, that question number 7. At time t, particle travel in a straight line. Acceleration is this. T equal to 0. Particle is 4 meter from fixed point. And then the velocity is 8. So we know that v is integrate a dt. So v will be integrate 2t plus 1 to the power negative half dt. Then it will be 2t plus 1 to the power half divided by half times 2 plus c. So when v equal to 8, t equal to 0. So c is 7. So v will be the 2t plus 1 to the power half plus 7. Okay. Find the displacement. So we know that s is integrate v dt. So s is integrate of this 2t plus 1 to the power half plus 7 dt. So this is equal to 2t plus 1 to the power 3 over 2 over 3 over 2 times 2 plus 7t plus d. So we know that when t equal to 0, s equal to 4. So we have 4 equal to 1/3 1 to the power 3 over 2 plus 0 plus d. So d will be 4 minus 1 over 3 is 11 over 3. So s will be 1/3 2t plus 1 to the power of 3 over 2 plus 7t plus 11 over 3. Okay, that's all for the hard question.